Professor Bialis here. In this video we're going to talk about section 7.2, which is talking about multiplying and dividing rational expressions. Okay, now let's write that down. Whatever rule we had for multiplying and dividing fractions, just normal fractions, will apply to this. Remember, a rational expression is a fraction. Okay, so just as a quick review, if we had, let's say, 2 over 3 times 3 over 4. Let's say 5 over 4. Say something like that. Okay, when we multiplied this, we had 2 times 5 is 10, 3 times 4 is 12. Okay, just multiplying across top and bottom. But remember, there was a side rule to that. Okay, after we multiply, we would have to reduce this by 2 to get a 5 over 6. But we could have done that in the beginning. Okay, so when we multiply this, we could have reduced first, then 1 times 5, 3 times 2. Okay, this is what we're going to be doing with rational expressions. We definitely don't want to multiply first, because multiplying polynomials brings us into distributing, and then to reduce them we would have to factor. Sometimes we're going to distribute and we're going to get this huge polynomial that we can't factor. Okay, so it's very important we try to reduce first. Okay, now remember, with reducing, we're reducing factors. Those are parts of products. This whole thing is a product. So, just as before, the rule is still going to apply here. Whatever is on the top can reduce with whatever's on the bottom. Okay? As long as they're the same. But anything along the numerator can reduce with anything along the denominator. Okay? So let's look at an example with some more algebraic expressions in it. Let's start simple though. So just think we're multiplying fractions. Forget that there's variables in there. To multiply fractions, we start by looking to see if anything reduces as is. In this case, this does not reduce. This does not reduce. So we just multiply across the top and the bottom. Simple as that. Okay? And there you go. That's really all there is to it. Let's look at another one. Okay, same idea, except can I reduce first? So I'm going to start here. -5 doesn't reduce, it does reduce. So I'm going to divide this by 5 to get a -1. Don't lose the negative. Divide this by 5 to make a 3. Okay? Then A doesn't reduce here, but it does reduce here. I have one of them is gone, and there's going to be 2 left. Think of it this way. I got 3 versus 1. This guy is going to lose. He's going to take someone with him, so there's 2 left on top. Then I go to here. 2 doesn't reduce with anything, but the B's reduce. 2 of them are gone, 1 of them's left. Now, if this starts getting too messy for you, feel free to rewrite it and rewrite it as many times as you need. You can reduce just one thing at a time and then rewrite it. Do what's comfortable. Now, what I'm doing at this point is just cleaning up. So I am then going to multiply across the top. -1 times 2 is -2. And then the only variable left is that a squared. Make sure you don't lose that exponent. In the denominator, 3 times 3 is 9. And then I've got a b. And there we go. Okay? Nothing more to it than that. Really, the issue here is you got to have good bookkeeping. You got to make sure that your markings are easy to read and you don't lose something when you're doing all that crossing out. So let's move on. about that? Okay, so again, we're multiplying. First thing we want to try and do is reduce, okay, or simplify first. Now, since we have polynomials involved now, remember, we need to factor in order to simplify. So to multiply, you need to reduce, but to reduce, you need to factor. So what we have here are 4 possible factoring problems to start. Now these are just regular constants, so I'm just going to bring that down. But this can factor with a GCF, and this is a difference of squares. We got that. Okay? Now, let's clean this up. This is where we cross out stuff on the top with stuff on the bottom. So 6 doesn't reduce with anything. X plus 1 sure does. And 14 reduces with 7. 7 divided by 7 is 1. 14 divided by 7 is 2. Now I see a lot of people want to reduce these, but they're on the same side. Okay, even if you wrote it like this, they kind of look like they're on opposite sides, they're still in the numerator. So these cannot reduce. They would just multiply, and then this carries over. As simple as that. And look at what we did. We took this really big expression, and it's just that. Okay, so that's what we're trying to do, what we're trying to accomplish with these problems. Let's look at another one. Okay, so again, we're multiplying, so we want to be able to reduce first, but with polynomials, we need to factor them in order to reduce them. So again, 4 factorings in 1. And guys, when I list that thought process, that's what we need to be aiming for. And that thought process is going to be very, very routine and repetitive through this topic. Okay, I need to multiply. In order to do that, I need to reduce. In order to reduce, I need to factor. Okay, so sometimes you need to say, this is what I ultimately want to do. What do I need to have that? I need to have this. I need to have this. I need to have this. Okay, and that's true with anything in life. You have to work from the bottom up. But if here's your goal, if you're saying to yourself, I want to be a doctor one day, then that's great. I want to be a doctor. What do I need to do? I need to go to medical school. Okay, I need to go to medical school. What do I need in order to get to medical school? I need to have good grades. I need to, and that's where, okay, what do I need to do today in order to get to there? That's the same thing that we're doing here. I want to get to my answer here, but what do I need to do along the way? Reverse engineer that if you need to. And that's how we should be thinking about anything. That's the beauty of math. I mean, yes, we're multiplying rational expressions, but if we really think about what's going on up here, that can be applied to anything in our life. Anything. When I was getting my master's in mathematics, not that long ago, but about 10 years ago, it was interesting to me that when I was doing that, I was getting better at fixing things around my house. I wasn't learning that stuff, but I could think critically. I could think better in an orderly fashion. So when something was broken, I could say, okay, what's broken? Where's that component? How is that component tied in? And I could kind of work backwards through things. That's the beauty of mathematical thinking. Okay, so don't forget that. Yes, on the surface we're just working with these, but there's so much more to it. Okay, so back to this. We're going to be factoring 4 possible terms. This one up here, I'm going to take a GCF of 4. And we got that. Now, this next one, I want to be very careful with that. Notice, this is an oddball expression compared to the others. Everything's in descending order except for this. So what I'm going to do, yes, I could take a 7x out, but better yet, I'm going to take a negative 7x out. Because that will allow me to flip over that minus sign. I've got x minus 2. Double check. Negative 7x squared, positive 14x. I'm good. Let's move on. I'm going to go to this to get difference of squares. And then over here I do guess and check. Okay, so I've got 3x and x. I'm going to have a plus and a minus. And then I'm going to go with, let's say 2 and 1. Let's check that. I've got negative 3x plus 2x. That's a negative 1x. That's not what I want. Okay, so let's try 2 here, 1 here. Negative 6x plus 1x, there's your negative 5. Okay, don't be afraid to guess something that doesn't work. Just guess something though. Just keep moving forward. If it doesn't work, you fix it. No big deal. Everything is factored. That's really where the work is in this problem. Now we need to reduce out. 4 doesn't reduce. X plus 2. Close, but that's not going to be fixed. Those are different. These cancel out, and then these cancel out. Okay, so what we're left with is in the numerator 4 times the quantity x plus 2, and in that denominator negative 7x, quantity 3x minus 1. And there you go. Again, some people want to distribute, don't even bother. Don't, just leave it. That's good. Negative, you can leave it there. You could pull it out to the front. You could pull it up to the top. It's up to you. Again, I would probably just leave it there. And there we go. Okay. Let's now move on to some dividing examples. And just as a reminder, if I'm doing an example here and you think you have it down, you think you got this concept, hit pause before I start my explanation. Work it out on your own, hit play, I'll be here waiting for you. Okay, so let's look at some division now. Let's start simple. Okay, now same as before, guys. This is just like a fraction, just like a normal fraction. Okay, when we divide fractions, what do? We keep this first one the same, and then we multiply by the reciprocal. That doesn't change. Okay, so now I'm back to multiplication. Really, division is a multiplication problem in disguise. Once we take that disguise off, we write it as multiplication, we're doing multiplication. And really, if you haven't noticed so far, multiplying is just one big simplify problem. We factor and we cross stuff off. So when we divide, we're really multiplying. And when we're multiplying, we're really just simplifying. Okay? So when I simplify this, x gone, 1x left, and then 2 reduces with the 6. And now let's see what we have left. 7x times y is 7xy. And 3 times 1 is 3. And that's it. Always verify that there's nothing more to simplify. You should be able to simplify everything you can over here, but if you miss something, you can always simplify at the end. Let's look at another one. Okay, again, first thing, I don't want to divide. I want to multiply by the reciprocal. We have that. Now we factor. Okay, now really there's not much to factor here because this is already good to go. Whoops. So are those. We've just got that. Okay? Now, let's reduce. Let's go with the 2 first. 2 divided by 2 is 1. 6 divided by 2 is a 3. Now, the quantities here, these will reduce the same way as a normal variable would. There's 2 of these, and then 1 of these. That one's gone, and 1 of them will be left. Okay? Now, these 3's, again, it kind of looks like they're on opposite sides, but they're both in the denominator, so they just multiply. So what we get is that x minus 4, and then 3 times 3 is 9. There you go. Okay? How about this? Now, we see that it's a division problem. Identify what it is and then have your plan of attack. Division problems, we multiply by the reciprocal, factor, reduce. Okay? So, first thing, we got that. Okay? Now, what I see some people do is they want to do that flipping move and factor at the same time. I really wouldn't do that because when you get so caught up in the factoring, a lot of times people forget to flip. Not that that's wrong to do it that way, but the more stuff you combine, the more likelihood you're giving yourself to make a mistake. Okay, so once we do the flipping and multiplying, let's factor. Give myself a place to go. I like to do the easy ones first because they can sometimes help you with the more complicated ones. So this is good to go. I'm going to put parentheses around that to remind myself it goes together. This is a simple difference of squares. This I could take a 2 out. And this I can take an x squared out. Okay? And now I just reduce. So 5x plus 2, x plus 2, and that's it. This quantity has a 2 in it, but it's a whole quantity that doesn't match with just this. So in the numerator, all I have is that 2, and the denominator, I have the x squared and x minus 2. And that's it. Simple as that. Okay? Let's do one more like this. And we're going to tie it all together. Okay? Now, I definitely want you to pause the video right now, try this one on your own. Okay? And I'll be back here waiting for you. Now, when we do this division, same as always, I'm going to first write this one down again, then multiply by that reciprocal. Okay? I then factor. Give yourself a place to go. This is just a 21. This takes a 7 out. This takes a 3 out. Okay? Now this is going to be a guess and check. So, I've got a 3x and an x. This tells me they're the same sign. This tells me they're both minus. Okay, now 8 could be 1 and 8 or 2 and 4. Now, this is what I meant by, doing the easy ones can help you with the more complicated ones. It would be really, really convenient if this quantity here matched this one. Okay? Make that your first guess. That doesn't mean that it's definitely going to work every time, but make that the first guess. If something's like, well, that would be really nice, try it. Okay? So I'm going to go with a 4 here and a 2 here. That gives me the 8. Okay, but let's make sure that it gives me this. I've got negative 6x minus 4x, negative 6 minus 4 gives you a negative 10. So that worked. Okay, so that's why I do these easy ones, because sometimes they give you a hint on what you should be guessing in those trinomials. And now we reduce. Gone. Gone. Now, the 21 reduces with 7 and 3. It does. Reduce with 1 at a time. Okay, I'm going to start with the 7. So 21 divided by 7 is 3. 7 divided by 7 is just a 1. But now notice, this leftover is still in play. So 3 and 3 reduce. Everything's gone. Now remember, all that reducing reduced to what? It reduced to a 1. I see a lot of students are like, well, that's kind of stupid. All that work for just a 1. That's a good thing. We should be excited. We took this big, nasty problem, and we have that. That's exactly what we want to happen. So that should be an exciting result to us when we get something so nice and clean. Okay, let's now look at this one. One last one. Okay, so for this, first thing we do, we flip the second one, correct? No, I did this on purpose because I want you guys to remember there's multiplying and there's dividing. This problem is a multiplication problem. All that means is that we need to factor and then simplify. Done. We don't need that first step where we flip that second fraction. So please pay attention to the problem itself. So this first one, all 4 of these can factor. I'm going to take a 2 out of here, and we got this. And then here, we got an x and an x. And then we're going to have a minus 3 and a minus 4. That gives us a 12, gives us a negative 7. This, be careful with a 6 and a 5. We're going to have a plus 5 and a plus 1. And then this, notice it's opposite order. So I'm going to take out, that negative, and we're here. Now I just reduce. Gone, gone. And all that's left is a negative 2 over x plus 1 and an x minus 4. Okay, so always start by identifying the type of problem it is. If it's multiply, you factor, you reduce, done. If it's divide, you flip that second one, and now it's multiply. So you factor, you reduce, you're done. Okay? As always, work hard. Let me know if you have any questions, and I'll see you next time.